Today, for the system design, we're trying to understand some uh, hashing technique, and also we can say caching mechanism like Redis. So we're trying to understand the Redis kind of uh, caching mechanism. So let's understand a little bit about the Redis, and then we'll think how the people has designed the Redis, or how we can design Redis kind of uh, caching mechanism. So in the caching mechanism, when there are a lot of data and we store that data in a database, and again we paste the data from the database, and that process will be slow in many scenarios where we need to find some key value pair of data, and every time you go to the database and get your record from the database, then there will be network latency. So to avoid those kind of database access, we have something in between, and that is called caching mechanism. So Redis like caching mechanism. So let's try to put some functional requirement, what we are going to think here. So functional requirement, and here I'm thinking to have uh, like design caching mechanism, uh, like Redis. So that is our one functional requirement, and we know caching mechanism, caching all the cache data that goes to the RAM. So that's just for the information. You just put there, and in this, if anything to design the caching mechanism, we need to think like how many requests can come. So you can think a million of the requests in the per second. So you can say query per second. It's a million. And if you think like this kind of request goes to the database, you can imagine, how much time it takes. It's a very long time uh, for the network delay, and even though like getting the data from the database. But if it is in RAM, all the data, if you put that in a RAM, then it will very fast. So so we need to think, but we cannot put all the data in the RAM, because there can be a terabyte of the data, and the RAM is costly. So something we need to have in this design, we need to have something like eviction policy. So if you design the caching mechanism, okay, we bring the data from database, put it there in a RAM, but in certain time we need to remove the data that's not used, or for certain time if it's not getting used, then get rid of that, and we can have like most recent data, we can put it there. So this is the functional requirement to understand this caching mechanism, and then there can be some non-functional requirement, NFR, and here I can just think, like it should be scalable. If there is a lot of data, it should be scalable. There can be horizontal scaling. You can do availability. So the system and design, that should be always available. So that's availability. So let's say if you have some variable, like hash table, map kind of hash table, and how to store the data in a hash table. So those kind of thing we need to think here, like some user will send some request, they want to get some data based on the key, and the key value pair they want to get that, then we can store in a hash table, and from there we can get back the key value. So how will you store? So let me put something here. Let me bring this one. I can say that's a hash table. Can I write here? No. And bring text inside this. Okay, so in a hash table, we know we can store the key value pair. So like let's say I want to store some data. So in the case of like the value, some value, like let's say string John. So if I get a John, so for the John, I need to have some algorithm, and based on that algorithm, I can get the key for the John, and that's some int value, and the always same value for that John. So let's say in this case, if I get some int value here, like let's say one, some int value is one, and then I want to store that value John itself. So that's my key. So based on some algorithm, I can get the key, and in a hash table we can store key value pair. So I can store the value next. So value one, like this. I can store value two, like this is for the John. I can say this is the RAM. So in this way, I can store the value. But we can also think when we design this caching mechanism, we need to think like sometime there can be key collision. So the key collision meaning when we have the John and then the value is one, maybe for the some other string, the value will be same. So if the value will be same, then how will you store that value? So in this case, we need to think a little bit deeper here. So in this case, we can think we can store this in a some linked list. So we can have a separate node, and then as soon as we get the John, we can put the John here, and then we can, if you get another name, again we can have another node there, and we can do those things here. So in this case, I'm not going to use the simple linked list, but in this case, I can use uh, the doubly linked list. So in a doubly linked list, and in that way also I want to. I'm just using the doubly linked list because I want to also use the eviction policy. And here in this case, if I use the John, then I'll put it here. Then another value I can put in another node. And if I access John again, I'll remove the John from here and I can put it at the end. So in this way, if I use the doubly linked list, I can get this in a constant time. So that's why I'm using that. So let me so that, like, let's say this is the one here. So in this case now, I'll just, instead of like storing the John, I'll just put the key here. So I'll just say, okay, I'll put the key here one, and but for this one, the value will be in this place. So for this key, if I get, then I can put this John here, and again for the same, for other value, and if you get the same key, then I can put that value here. Just for example, I just put, it's not like the same key, but I'm just assuming, like let's say the Son has also same key, then I can put this way, and I can put the doubly linked list here. So let me, yeah, this is the good one. Okay, so in this way, and in this way, I can have also a eviction policy. There will be some process running in a background and check, like on certain, the size, it will check, will fix some size of this hash table. Like if it is more than some uh, like GB or 1 GB, 2 GB, we can in a slice that size of this. And if it is more than that, or based on some timing also, like if this item is not accessed uh, for like 30 seconds, then okay, get rid of this. And if you use this again, you put it, delete from here and put it here. So in this way, we can also keep cleaning uh, uh, the data that's not used. So that's the basic design we have put. And then in this way, we can also use the eviction policy. And then in this way, we also keep clearing unused data here in the memory. So yeah, so that's one thing. Another thing just I want to talk in hashing, I mean this caching mechanism, that this is handled by a server. So let's have a server here, server one. And what happened, server goes down, then how to retrieve the data back. So so for so that's the one problem. Another thing is, the if there is a one server and the server's down, there is no like availability. So we can have the multiple servers we can have here. Can have multiple server, and we can also do some mirroring here for the same server. We can do some mirroring. In this way, if you one the server is down, another server is available, and in that way our system is always available. So that's the one thing we need to keep in mind. And if the server is like in the case, all the server got crashed somehow, and if you want to get back all this data, then there can be different technique. One of the technique, I think I remember just now, like we can have the logging, and in the log we can put this key value. And then when the server is down, we still have the log, and that is in our file system. And from this file system, we can read the log, and from the last, we can take the snapshot for that log. And then snapshot is like some time period, and within the time period, whatever the logs we have got, again we can put it back to a hash table. So we can write a script that runs in a background in the case of system crash. So now based on, if you like, once we have the this understanding, now let's have put that one image how it happens. Like let's say there are uh, get put call, API call, or directly get put call directly with the server, like how we do in a Redis. So let me write here. So get put call, and there will be a lot of requests that goes to server. So that's a server, and here we have the load balancer. We can have all mirroring, and everything is here in this server. And when a lot of the requests come, we do not directly go and put that in a hash table, because if the request is more, then putting in a hash table directly, that's also again the time consuming. So what we usually do, we store this thing in a queue. So let me bring this thing. So this is the queue. So we'll put that in a queue, and that is a two-way process. So okay, so let me show that first. Whenever the some get put call request comes to the server internally, we put that in a queue. And then from the queue there will be multiple threads here, and these multiple threads keep working on the queue. And then this their job is get or put based on the request, they get the data and store to RAM. So here I can put that's in a RAM, and, and this is both side, all because we need to put that, we need to get that. So this direction is both side. Duplicate this here also, and yeah, so that's all about the simple process. And request comes, goes to the server, put that in a queue, multiple threads, and keep putting in a RAM. And when you put that in a RAM, we need to design this kind of algorithm. uh, it has stable, and it has stable when something comes, how we manage with the node. So those kind of things. So that's all about, so just the basic things about the Redis, how the Redis work, or how we design this caching mechanism. So thank you.